Hi, welcome back. I'm Rakesh Naik. Today we are going to see about comparison between asymptotic functions. Before we start, a small request: if you're a new user, please press the subscribe button below so that you will get all the updates. So let us start. We have already learned how to find the asymptotic function of different programs or different algorithms. Basically, we have learned the measuring of the performance of an algorithm in relation to the input size, and it is called as order of growth. So here you can see the different order of growth. It can be log base to n, it can be n, it can be n log base to n, it can be n square, n cube, or 2 to the power n. Basically when we say order of growth, in other words, we mean to say which function is approaching infinity faster. So in order to find that, there are some thumb rules we need to apply. First of all, we need to drop all the constant factors from the very beginning. Drop the lower order polynomials, those are not required. Any polynomials that dominates, all those things also will eliminate. Exponential functions dominates polynomial function, that we need to keep in our mind. And x to the power n dominates y to the power n for x is greater than y. So these are the basic rules that we are going to follow. In order to compare two functions in their rate of growth, there are two basic methods. One is logarithmic method, another is L'Hospital method. So let us try to understand one by one and do some problem based on that. So let us try to see the logarithmic method first. So before we start, let us try to see some identities or some rule that we'll be frequently using. We know that 2 to the power 3 equal to 8. And if we want to write it in the form of log, it will be nothing but log base to 8 equal to 3. We'll write it in this form. So other rules are log n is a power to which you raise 2 to get n. And some important results are log 2 to the power n equal to n. Log x to the power y is nothing but y log x. Log x y equal to log x plus log y. Log base to x is equal to log base k x by log base k 2. Similarly, log 2 to the power log n is nothing but n. 2 to the power x to the power y is nothing but 2 to the power xy. 2 to the power x into 2 to the power y is nothing but 2 to the power x plus y. So we use these standard rules or identities to find the rate of growth. We'll compare two functions. Let us see one example. If first function is 3n cube and second function is 5n log n, then we need to find which function is having higher growth rate or which function will approach infinity fast. That's what we are going to see. So what is the first rule? Drop all the constant from the beginning. It means here 3 and 5 are the constants. We'll drop it. So fn becomes n cube and gn becomes n log n. So these two we are going to compare. Now take log both sides. So log of fn becomes log of n cube and it is nothing but 3 log n. Similarly, on the other side, so for gn also log gn we want to take. So log n log n. So it is nothing but log n plus log n. So what we'll be having, we can cancel out log from both of it. So we need to compare 2 log n and log n. So we know that 2 log n is greater than log n. So that's why fn function is having higher growth rate than gn. Hope you understood this. If you have not understood, we'll do few more examples. Keep watching this video. Now we'll see L'Hospital method. If you remembered L'Hospital method, we learned it in limit in our intermediate days. So what is that? If limit fn by gn as n tends to infinity is in the form of either 0 by 0 or infinity by infinity, we apply L'Hospital rule. What is L'Hospital rule? Numerator and denominator function will differentiate. Again, we'll take n tends to infinity, and again if it is in infinity by infinity or 0 by 0 form, again we'll differentiate it till we get a finite value for numerators and denominators for these functions as n tends to infinity. If fn is greater than 0 and gn is greater than 0 for all n greater than or equal to r, where r is some real number, then these are some standard functions that we'll be using. Like if limit fn by gn equal to infinity as n tends to infinity, then we'll say fn is having higher growth rate than gn. If limit fn by gn equal to some constant, then that's supposed to be greater than 0, then again we'll say fn is having higher growth rate than gn. And if limit gn by fn equal to 0 as n tends to infinity, then gn is having higher growth rate than fn. So you want to apply these three formula to find the growth rate or compare growth rate of two functions. So let us take an example. We'll apply this formula to compare two functions. So let us see with help of an example. fn equal to 3n cube and gn equal to 5n square. We want to compare which function is having higher growth rate. So what we need to do, we need to drop the constant from the very beginning. It means fn becomes n cube and gn is n square. So now take limit. So limit fn by gn, it means n cube by n square as n tends to infinity. So if we'll substitute infinity, it is in infinity by infinity form. So we can apply L'Hospital rule. So what we have to do, we have to differentiate it. So n cube's differentiation is 3n square and n square differentiation is 2n. So limit 3n square by 2n as n tends to infinity. This is also in infinity by infinity form. So that's why again we'll apply L'Hospital rule. So 3n square's differentiation is 6n and 2n's differentiation with respect to n is 2. Now the limit as n tends to infinity, it becomes infinity. So that's why we can say 3n cube grows faster than 5n square. Let us see some more problem based on these two methods. Now let us check fn equal to log n to the power half and gn equal to log n. We need to find the rate of growth. So what we need to do, drop constant. So there is no constant, nothing to drop here. So as usual fn and gn we are going to compare. So we need to take log both sides. So it becomes fn becomes half log n and gn becomes log n. If we'll substitute n equal to 2 to the power 10, so we'll have half log n. In place of n we are substituting 2 to the power 10. So in place of n we substituted the value and we applied the formula. So it becomes half log 2 to the power 10. Here also log 2 to the power 10. Now log 2 to the power 10 is 10. Here what we'll do? Here also log 2 to the power 10 is 10. So the value becomes half into 10, that is 5, and log 10, the value is 3. So we can very well say 5 is greater than 3. So fn grows faster than gn. Let us take one more example. fn equal to 3 to the power n, gn equal to 2 to the power n. We need to drop the constant at the beginning. So there are no constants. So fn and gn as it is we want to compare. Take log both sides. Log fn becomes n log 3 and log gn becomes n log 2. If you cancel n from both sides, we need to compare log 3 and log 2. Obviously log 3 is greater than log 2. That's why fn has having higher growth rate than gn. Let us do one more problem. fn equal to n to the power log n and gn equal to n log n. Now we want to compare this. So first we need to drop the constant. We have done it. Now take log both sides. So log fn becomes log n and log gn becomes log n plus log n. So again substitute n equal to 2 to the power 10. So we'll get log n becomes 1024 into 1024 and log n plus log n becomes 1024 plus 10. So Fn is having higher growth rate than Gn. Let us take one more example. Fn equal to 3 into e to the power x, Gn equal to 5 into x to the power n. We need to find which is having higher growth rate. So initially we need to drop the constant. So Fn becomes e to the power x and Gn becomes x to the power n. So take limit Fn by Gn as n tends to infinity. It becomes limit e to the power x by x to the power n as n tends to infinity. So it is an infinity by infinity form. So we'll apply L'Hospital rule. So we'll differentiate the numerator and the denominator. So e to the power x differentiation is e to the power x. X to the power n's differentiation with respect to x is n into x to the power n minus 1. As n tends to infinity, again it is an infinity by infinity form. So if we'll keep on doing it like this till n time, what we'll get? At last we'll get limit e to the power x by n into n minus 1 into n minus 2 up to 1 as x tends to infinity. This value becomes infinity. So 3 e to the power x is greater than 5 x to the power n. So Fn is having higher growth rate than Gn. We'll see the last problem here. Fn equal to log x and Gn equal to x. So which is having higher growth rate. So what we need to do? We need to take limit. So limit log x by x as x tends to infinity. It is in infinity by infinity form. And if we are differentiating, we'll get limit 1 by x by 1. So as n tends to infinity, this value becomes 0. So log x is having less growth rate than x. Thank you for watching this video till the end. Keep watching, keep learning, and if you are a new subscriber, please subscribe it and press the bell button so that you will get all the notifications. Do share with your friends also. Thank you.